The Bermuda Triangle, an area of the North Atlantic Ocean bounded roughly by Miami, Bermuda, and Puerto Rico, has captivated the imagination of the public for decades. Often referred to as the Devil's Triangle, it has been linked to countless stories of ships and aircraft disappearing under mysterious circumstances. From the disappearance of Flight 19, a squadron of U.S. Navy bombers in 1945, to vessels like the USS Cyclops and the Carroll A. Deering, the region has become synonymous with inexplicable phenomena, drawing explorers, journalists, and conspiracy theorists alike. Even in the age of satellites and GPS navigation, the Bermuda Triangle continues to evoke a sense of awe, fear, and curiosity that few other geographic locations can match. The area is notorious not only for the sheer number of reported incidents, but also for the seemingly inexplicable nature of these events. Accounts describe sudden vanishing acts, mysterious electronic malfunctions, and even bizarre weather patterns appearing without warning. Popular media has contributed to the mystique, embellishing stories with sensationalized details of vessels swallowed by whirlpools or aircraft vanishing in midair. Over time, the Bermuda Triangle has transformed from a navigational hazard into a symbol of the unknown, a place where science folklore and human imagination intersect. Yet beneath the sensationalism lies a fascinating intersection of geography, meteorology, and oceanography. The Bermuda Triangle is located in one of the busiest shipping lanes in the world with complex currents and unpredictable weather systems. Tropical storms, hurricanes, and rogue waves are common, creating conditions that even modern ships and aircraft find challenging. The Gulf Stream, a powerful and fast-moving ocean current, further complicates navigation, often dispersing debris quickly and making accident reconstruction difficult. These natural factors alone offer potential explanations for many of the mysteries that have been reported over the years. Despite these practical considerations, the legend of the Bermuda Triangle persists, fueled by decades of anecdotal reports books and television programs. The very absence of definitive explanations has amplified the sense of mystery, leading to theories that range from alien abductions and time warps to underwater cities and magnetic anomalies. In reality, much of the mystery stems from human perception and the tendency to connect unrelated events into a compelling narrative. Nevertheless, the Bermuda Triangle remains an iconic symbol of unexplored frontiers, challenging our understanding of nature and human psychology alike. Recent studies, however, suggest that while the triangle is prone to certain dangers, many reported disappearances can be attributed to a combination of environmental factors, human error, and statistical probability. Yet the fascination endures precisely because the area blends the known with the unknown, creating a space where extraordinary claims meet scientific investigation. As we delve deeper into the truth about the Bermuda Triangle, it becomes clear that separating fact from fiction requires a careful, methodical examination of historical data, oceanography, meteorology, and human behavior, much like uncovering other ancient or enigmatic mysteries that have long captured the human imagination. Over the decades, countless stories have emerged from the Bermuda Triangle, each adding layers to its enigmatic reputation. Among the most famous is the disappearance of Flight 19 in December 1945, a squadron of 5 U.S. Navy TBM Avenger bombers on a routine training mission. All 14 airmen vanished without a trace, and a rescue plane sent to search for them also disappeared, compounding the mystery. These events were widely reported in newspapers and later sensationalized in books and documentaries, embedding the incident in public consciousness as a quintessential Bermuda Triangle story. Other accounts involve ships from commercial vessels to naval transports. The USS Cyclops, a massive Navy collier, disappeared in 1918 with over 300 crew members aboard, and the Carroll A. Deering, a 5-masted schooner, ran aground in 1921 under circumstances that remain unresolved. Eyewitness reports often describe sudden, inexplicable weather events, unusual fog, or electronic malfunctions that foiled navigational instruments. Such reports, while sometimes lacking corroborating evidence, have fueled the perception of the Triangle as a region where ordinary rules of navigation seem suspended. Folklore and popular culture have further amplified these accounts. Writers and television programs often portray the Bermuda Triangle as a place of supernatural activity, vessels pulled under by massive whirlpools, aircraft caught in unseen vortexes, or even encounters with alien or interdimensional forces. These narratives, though speculative, resonate with a human fascination for the unknown. Stories of ghost ships, eerie lights on the horizon, and compasses behaving erratically have been passed down, creating a rich tapestry of legend that blurs the line between anecdote and mythology. It is also important to consider the role of narrative embellishment. Many reports have been dramatized with details altered or exaggerated over time. Survivors' accounts, news reports, and sensationalist books often emphasize mystery and danger, sometimes overlooking mundane explanations such as navigation errors or adverse weather. Nevertheless, these stories have captured imaginations worldwide, turning the Bermuda Triangle into a symbol of uncertainty and intrigue, where ordinary maritime and aeronautical challenges are transformed into tales of the supernatural. The persistence of these legends highlights the interplay between human perception, memory, and storytelling. People naturally seek patterns and causation, often linking unrelated incidents into a coherent, albeit fantastical, narrative. In the case of the Bermuda Triangle, the combination of a high volume of maritime traffic, unpredictable weather, and remote location creates fertile ground for myth-making. While the legends captivate the imagination, they also obscure the underlying mechanisms that, when analyzed scientifically, provide far more plausible explanations for the purported anomalies. Scientific investigation of the Bermuda Triangle has long focused on natural and human factors that could account for the region's mysterious reputation. Foremost among these are the unpredictable weather patterns common to the area. The triangle lies within a region prone to sudden thunderstorms, tropical storms, and hurricanes, particularly during the Atlantic hurricane season from June to November. Violent squalls and high winds can appear with little warning, creating conditions that challenge even experienced navigators. For ships and aircraft operating before modern meteorological forecasting, these storms posed serious risks that could easily result in accidents and disappearances. Ocean currents are another significant factor. The Gulf Stream. A powerful, fast-moving current running through the Bermuda Triangle can move floating debris quickly and unpredictably. A vessel encountering engine trouble or navigational difficulties could be swept off course within minutes, making it difficult to locate or rescue. Similarly, any wreckage that remains afloat could be rapidly carried far from the incident site, complicating efforts to investigate disappearances and leading to the impression that vessels vanished without trace. Human error further contributes to the phenomenon. The Bermuda Triangle has historically been one of the busiest shipping lanes in the Atlantic, with heavy traffic from commercial, military, and private vessels. Navigational mistakes, miscalculations, or mechanical failures can have catastrophic consequences, particularly when compounded by sudden weather changes. Pilots and mariners relying on early instruments, often without backup systems, were especially vulnerable to disorientation or misjudgment, which could explain a significant proportion of reported accidents. Additionally, the region is known for the presence of deep underwater topography, including the Puerto Rico Trench, the deepest part of the Atlantic Ocean. This trench could contribute to rapid sinking of vessels, while strong currents within the trench may disperse debris, leaving minimal physical evidence. Geological activity, including occasional methane hydrate eruptions from the seabed, has also been proposed as a mechanism that could reduce water density locally, potentially causing ships to sink abruptly. While such events are rare, they illustrate the complexity of environmental hazards present in the triangle. Collectively, these factors, unpredictable storms, powerful currents, human error, and unique geological features offer plausible explanations for many of the incidents historically attributed to the Bermuda Triangle. Far from requiring supernatural or extraterrestrial explanations, scientific evidence suggests that the so-called mystery can largely be understood through a combination of environmental, mechanical, and human variables. The challenge lies in separating the legend from factual occurrences, assessing each incident individually, and recognizing the role of statistical probability in a region where high traffic and natural hazards inevitably result in occasional disappearances. In recent years, new research has begun to shed light on the Bermuda Triangle, challenging many long-held assumptions. Advances in oceanographic mapping, satellite monitoring, and physics-based analysis have provided unprecedented insight into the forces at play in the region. High-resolution seabed surveys reveal complex underwater topography, including steep continental slopes, deep trenches, and irregular seamounts. These features can generate localized turbulence, unusual currents, and even sudden whirlpools, providing a natural explanation for the rapid disappearance of smaller vessels and the dispersal of debris. One particularly intriguing area of study involves the role of methane hydrates, frozen compounds found beneath the seafloor. Under certain conditions, large pockets of methane gas can erupt into the ocean, drastically reducing the density of surrounding water. If a ship were situated above such an eruption, buoyancy could be temporarily compromised, potentially causing it to sink almost instantly. While these events are rare, computer simulations suggest that even isolated occurrences could account for some of the most mysterious disappearances historically attributed to supernatural causes. Modern meteorology has also contributed valuable insight. Satellite data now allows researchers to track sudden microbursts, rogue waves, and rapid atmospheric pressure changes with remarkable precision. These phenomena, which can appear without warning, pose significant hazards to both maritime and aerial navigation. For aircraft, sudden wind shear or turbulence can overwhelm early autopilot systems, while vessels may be caught off guard by rogue waves capable of reaching heights exceeding 20 meters. These natural hazards, when combined with human misjudgment, may explain many of the incidents that once seemed inexplicable. Furthermore, the application of physics and computational modeling has allowed scientists to recreate historical accidents, simulating the effects of currents, winds, and waves on drifting or disabled vessels. These studies reveal that objects in the triangle can be displaced over hundreds of kilometers within days, often leaving little trace. In some cases, radar tracking and sonar data show unusual wave patterns that could interfere with navigation systems, compounding the risk of accidents. When analyzed collectively, this body of evidence suggests that environmental complexity rather than supernatural intervention accounts for the majority of reported phenomena. Interestingly, multidisciplinary research has also examined human perception and reporting bias. Many reported disappearances involved vessels operating under conditions of poor visibility or during periods of high storm activity. Survivors' accounts frequently describe exaggerated or misinterpreted events influenced by stress fear or media narratives. When combined with the aforementioned environmental factors, these human elements help explain why the Bermuda Triangle has acquired such a disproportionately mysterious reputation, despite its proximity to heavily trafficked shipping lanes and air routes. Taken together, these modern discoveries fundamentally reshape our understanding of the Bermuda Triangle. Rather than a site of paranormal activity, the region emerges as a complex environment where rare but natural phenomena interact with human error stress and limited historical technology. These insights demonstrate the importance of rigorous evidence-based investigation, revealing that the Bermuda Triangle's enduring mystique is as much a product of perception and storytelling as it is of genuine environmental hazards. While mysteries remain, science provides a framework that explains the vast majority of incidents without recourse to extraordinary or supernatural explanations. Empirical data collected through modern technology has significantly enhanced our understanding of the Bermuda Triangle. Satellite imaging, radar monitoring, and sonar mapping have provided concrete evidence that many supposed mysteries can be explained through natural phenomena. High-resolution satellite photos reveal patterns in ocean currents and sea surface temperatures that correlate closely with historical incident locations, suggesting that strong currents and temperature anomalies may disorient navigators or accelerate the dispersion of wreckage. Radar data collected from commercial aircraft and ships highlights the frequency of sudden squalls and microbursts in the region. These events, often invisible to the naked eye until they strike, can generate extreme wind shear, rapidly increasing the risk of accidents. Modern analysis shows that small aircraft caught in these conditions can experience loss of control within seconds, while ships can encounter waves exceeding 15 to 20 meters capable of overwhelming smaller vessels almost instantaneously. Oceanographic surveys further reveal the influence of the Gulf Stream, which acts as a powerful conveyor belt, rapidly transporting floating debris far from its original location. Historical searches for wreckage frequently failed, not because objects vanished mysteriously, but because the debris had been displaced by currents at speeds of several kilometers per hour. Similarly, sonar scans detect irregular underwater topography, including ridges, trenches, and sudden drop-offs which can generate turbulence, and localized waves that challenge both navigation and stability of vessels. Methane hydrate eruptions also provide a plausible physical mechanism for sudden sinkings. When large pockets of methane gas escape from the seabed, the surrounding water becomes less dense, effectively reducing buoyancy. Ships or smaller boats directly above such an event could theoretically lose flotation almost instantly. While evidence of active methane eruptions remains rare, the combination of topography, current, and gas pockets contributes to an environment in which sudden maritime disasters are possible even without human error. In addition, cross-referencing historical data with environmental conditions demonstrates a strong correlation between reported incidents and periods of high storm activity or peak hurricane seasons. Analysis of past disappearances shows that many occurred during times when weather forecasting was primitive or non-existent, emphasizing the role of natural hazards. Radar and satellite records now confirm that such conditions are not anomalous but recurring, providing a rational explanation for patterns long interpreted as inexplicable. Collectively, these empirical data points illustrate that the Bermuda Triangle's reputation owes as much to environmental complexity, natural forces, and human perception as to any true mystery, reframing our understanding of the so-called Devil's Triangle in a scientific light. The enduring mystery of the Bermuda Triangle is not only a matter of natural phenomena, but also a reflection of social perception and media influence. Over the decades, newspapers, books, and documentaries have sensationalized incidents, emphasizing unexplained disappearances and mysterious forces. Flight 19. The USS Cyclops and other notable cases were repeatedly dramatized, often with embellishments that ignored mundane explanations, such as navigation errors or storms. This process of amplification has created a feedback loop where legend informs perception, and perception reinforces legend. Psychological factors also play a role. Humans have a tendency to seek patterns and causation even where none exists, linking unrelated incidents into a compelling narrative. When a plane or ship disappears in the triangle, it is interpreted not merely as an accident, but as part of a larger enigmatic pattern. Cognitive biases, such as confirmation bias, ensure that observers remember extraordinary stories more vividly, reinforcing the perception that the Bermuda Triangle is inherently dangerous or supernatural. Media coverage contributes heavily to this phenomenon. Authors and television producers often highlight the most sensational elements: missing vessels, electronic malfunctions, sudden storms, while downplaying cases with mundane explanations. Phrases like Devil's Triangle or Mystery of the Lost captivate audiences, creating a mythos that transcends actual data. As these stories circulate, the legend grows, encouraging subsequent reports to frame incidents within the established narrative, regardless of scientific analysis. Public fascination is further fueled by the isolation of the area and the relative difficulty of verifying historical accounts. In the pre-satellite era, many incidents could not be fully investigated, leaving gaps filled by speculation. Even today, satellite and radar data have limitations, and the sheer scale of the Atlantic Ocean allows for rapid dispersion of debris. The combination of real hazards and limited verification opportunities ensures that uncertainty persists, which the human mind interprets as mystery. In essence, the Bermuda Triangle phenomenon represents an intersection of environmental hazards, human error, and narrative construction. While science can explain most incidents, the social and psychological components ensure that the legend remains compelling. Stories passed down through generations, amplified by media and human cognitive tendencies, transform natural risks into mythic enigmas. The result is a region that is simultaneously scientifically explainable and culturally enigmatic, demonstrating how perception, storytelling, and psychological factors can perpetuate a sense of mystery that persists even in the face of rational explanations. Taken together, the evidence suggests that the Bermuda Triangle's reputation as a site of mystery and supernatural phenomena is largely the product of natural hazards, human error, and narrative amplification. Unpredictable weather, including sudden storms, hurricanes, and microbursts, combines with strong ocean currents like the Gulf Stream to create conditions that can rapidly disorient navigators and sweep away debris, making reconstruction of incidents challenging. Methane hydrate eruptions and irregular seabed topography may provide additional, though rare, explanations for sudden sinkings. Modern radar satellite monitoring and sonar mapping have confirmed that environmental hazards account for most documented incidents, while psychological factors, media sensationalism, and cognitive biases have amplified the perception of mystery. Human tendencies to perceive patterns and to interpret coincidental events as connected have contributed to the enduring legend of the Triangle. Similarly, incomplete historical data and isolated incidents were often exaggerated, reinforcing public fascination and myth-making. Yet questions remain. Could there be rare, unexplored phenomena that contribute to unusual occurrences? How do perception and storytelling influence the reporting of accidents in other high-risk areas? The Bermuda Triangle exemplifies the intersection of natural science, human psychology, and cultural narrative. Understanding it fully requires careful analysis, critical thinking, and an appreciation of how mystery often arises where known hazards meet human imagination.